Hi, welcome to my channel. Well, today I'm gonna be showing you guys how to do an FRQ of the AP Calculus FRQs from 2016, and we're actually gonna be working on question number 2. Question number 2 states it says for t greater or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by bt equals 1 plus 2 sine t to the power 2 divided by 2. The particle is at position x equals 2 at time t equals 4. At time t equals 4 is the part. Sorry, that was my own fault. Question A of 2A, it basically says at time t equals 4 is the particle speeding up or slowing down. So what you gotta do, first of all, before you start A, you make sure to write down bt. So you're gonna go to y equals and then type in 1 plus 2 sine t squared over 2. And then what you want to do from there is you want to graph it. Also make sure you're typing it right, because if you miss a little mistake, it's going to change the whole graph. As you could see here, the graph, like, it's basically saying that you could see like so many lines you can't even really tell, but we're looking the graph from x equals 0 to x equals 4. So what I did here, as you could tell, is negative 10 as x min, and then I just put it to 0. And also for x max, I put it to 4. And with the y min, I put to negative 1, and y max to 5. So as you could see, that's what we're going to be working on. That's the part of the graph that we're going to be working on today. So what you need to do for letter A is basically you need to find b of 4 and a of 4. As you know, that b, it stands for velocity, a for acceleration. If velocity is positive and acceleration is negative, the particle is going to be slowing down. So basically opposite sign, they're going to be slowing down. Equal the same sign, they're going to be speeding up. So as you could tell here, I'm going to find b of 4 first, because that's the graph that I have right now. So you're going to do per second trace, then value, and you want to press enter, and then once you press enter, just press number 4 and then enter again, and then you're going to get 2.9. And you don't really care about the other number, because all you want to know, all they're asking is the particle speeding up or slowing down. Actually writing down the whole numbers, but yeah, you don't need to. And as you could say, so you could tell, it's a positive number. Now what you want to do is basically find the derivative of velocity, which it's gonna give you acceleration, and we're trying to find out 4. And then once you do dy over dx on your calculator, then just press number 4 and then press enter, and that's gonna give you the part where a of 4, and which is negative 1.164. As you could tell, one is positive and the other one is negative. Therefore, the particle is slowing down. So this is what I wrote. The particle is slowing down. The particle at t equals 4 is slowing down at t equals 4, since b of t is positive. I really meant to put b of 4, and a of 4 is negative. Therefore, the particle is slowing down, because opposite sign means they're slowing down. So you have a car, let's say you're running forward, someone push it back, giving you negative force, you're gonna slow down. But if you're running forward and then someone push it from the back, that's positive energy, that's gonna make you increase. Now we're gonna be working on letter B. Letter B says find out times t in the interval from 0 to 3 when the particle changes direction. Justify your answer. So basically from 0 to 3, we're gonna see on the graph where it changes directions. Changes the direction. Basically changes size from positive to negative. That's the graph. We're basically gonna press second trace, and then all we're gonna do is basically find the 0. As we know, it's from 0 to 3, so as you could say 1 to 3. So as you see on the right, there's another one, but we don't really care about that one because that's above 3. So what we do is basically find the left bound and then the right bound, and then we're supposed to guess, and whatever we get, that's gonna be answered. We don't look on the right one because that's above 3. That's actually like 3 point something. So yeah, that will be our answer, whatever we get from when we do the 0 value. Sorry about the blurriness right here. It's just that I didn't notice it didn't focus, but I'll fix that in a bit. And boom. So what we got actually with finally, like when it changes direction, is when x equals 2.707468. So what I did, I wrote down the particle changes direction at x equals 2.707468. It changes sign at that x value because b of t goes from positive value y value to negative y values, and it passes from the x-axis. Now that we finished B, we're gonna move on to C. So C says find the position of the particle at time t equals 0. So what we're gonna do is basically do the interval from 0 to 4 bt and dt. Then you're supposed to make it equal to x of 4 minus x of 0, because we're trying to find the position of the particle at time t equals 0. So what you gotta do, use your algebra skill, add x of 0 and subtract the interval from 0 to 4 bt dt, and we're gonna switch side because we're trying to find x of 0. And how did we got x of 4 is because that's our overall graph is from 0 to 4, so we do it from the top to bottom. So now our new equation is x of 0 equals x of 4 minus the interval from 0 to 4 bt dt. Once you do all this, basically plug it in on your graph, and your answer should be negative 3.815027. Now that we're done with C, we're gonna move on into D. D says find the total distance that the particle travels from time t equals 0 to time t equals 3. So what we're gonna do is basically do the interval from 0 to 3, and as we know, total distance means absolute value of b of t in this case. So total distance means absolute value. So you gotta remember that on the FRQ in order to get it right. So what we're gonna do is just plug it in there, and then I'm not even gonna show you the graph because all you gotta do is just basically put absolute value. And once you do that, from the interval 0 to 3, once you do that, your answer should be 5.3012044428. And these are basically the correct answer for FRQ 2016 AP Calculus. Now, question number 2. So I hope you guys enjoy, and please leave a like, and shout out to Mr. Coronel, the best teacher, the best math teacher.